Hello friends, in this video we will solve the famous quarantine puzzle which is being viral these days. We will use graph theory to solve this puzzle. Let's look at the puzzle. Here we have been given 16 isolated rooms of a hospital having one patient in each room with different illness. The patient in room number 13 has recovered and he wants to say goodbye to each patient before going back to home. Now, the condition is that he can visit to each patient exactly once to be safe from infection and to make exit from room number 4. So, how to translate this problem in a graph theoretical problem? First, we will construct a graph using the following rules. So, rule number 1, we represent each room by a vertex. Second, we join two vertices by a line if their corresponding rooms are adjacent to each other and there is a gate to pass from one room to the other. To draw the graph, we use the website www.graphonline.ru/en, where en stands for English language. Starting with adding vertices corresponding to 16 rooms, we will add 16 vertices. We connect two vertices if the corresponding rooms are adjacent. Here is our graphical representation of 16 rooms in the puzzle. You can see from room number 1 we can go to room number 2 and room number 5. So in the graphical representation, vertex 1 is adjacent to vertex 2 and vertex 5. Similarly, room number 6, from room number 6 one can go to room number 2, 5, 7 and 10. So the vertex 6 is adjacent to vertices 2, 5, 7 and 10. Now we are required to find a path from patient 13 to patient 4, visiting each patient exactly once. In graph theoretical sense, the problem is equivalent to the problem of finding the Hamiltonian path, that is, a path in which each vertex of the graph appears exactly once, starting from room number 13 and ending at 4. To find Hamiltonian path, let us go back to the website Graph Online. Click on Algorithm and choose the option of finding Hamiltonian path. But what we find is that Hamiltonian path given by algorithm does not start and end at our desired vertices. But since the algorithm to find Hamiltonian path on the website is inbuilt and there is no option to choose the initial and end vertex, to overcome this limitation, we add pendant vertices attached to both vertex 13 and vertex 4, which will force the algorithm to generate Hamiltonian path with our desired starting and end vertices. So let us go back to the website Graph Online and add the pendant vertices. Now let us generate the Hamiltonian path. We see that the graph does not have Hamiltonian path. Here comes the main trick of the problem. Notice that to avoid infection, the patient 13 can visit each room exactly once, but he can always come back to his own room as there is no chance of infection from his own room. Now the question is how we can bring it in our graph. Since in Hamiltonian path we are not allowed to repeat any vertex, what we can do is we can add a duplicate vertex 13 star of 13 and connect it with neighbors of 13. I am adding 13 star to the graph and connecting it with 9 and 14. Now let us find the Hamiltonian path of this graph. Here is our Hamiltonian path starting and ending with pendant vertices. By removing pendant vertices 17 and 18, we get this path. Replace 13 star by 13 and we get our desired solution. Let us see how it looks in the given puzzle.